All right. Chapter 4, question 144. Metallic aluminum reacts with manganese dioxide at elevated temperatures to form manganese metal and aluminum oxide. A mixture of the two reactants is 67.2% aluminum. Find the theoretical yield in grams of manganese from the reaction of 250 grams of this mixture. Okay, so we're going to write out the equation here to start. So we've got metallic aluminum, right, and we had manganese dioxide, so MnO2. This is reacting under elevated temperatures to form aluminum oxide. Aluminum has an oxidation state of 3+, so that's going to be the form there, and it's going to have manganese metal left over. Okay, let's do some balancing here. So, manganese. I'm going to do this. Well, if I do two aluminums, let's do those. Okay, so this is going to have to be 2, and that's going to have to be 3, and then that's going to have to be 3. All right, there we go. There's our balance reaction. And we know that this is 67.2% molar percent aluminum. In these reactants here. This is 67.2% of moles of aluminum. And what that means is that if we had 100 moles of this, 67.2 moles would be aluminum. All right? And we're going to write this a little differently. We're going to write, so like moles of aluminum, right, plus the moles of manganese dioxide, right? We're just going to say that these equal 1, right? This would be, we're going to use the percentage. This would be 0.672, right? And that is going to give us the moles of manganese dioxide, because it's going to be the difference between 1 and 0.672, right? This is just the decimal version of the percentage that we have here. So that means that for moles of manganese dioxide, we have 0.328. Okay, so let's tuck these off to the side. Let's write them over here. So we got moles of aluminum, 0.672. Didn't really need to rewrite that, I guess. Moles of manganese dioxide is the difference between 1 and that. All right, so there's that. So from those two, we're gonna find our limiting reagent. So we're going to do this the faster way too. So before I was writing these out longhand, now we're just going to react them. So 1 mole of aluminum is going to react with, this is 3, so this is going to be 3 over, this should be, yeah, sorry, I did 2. Wrote this wrong. This should be a 4. Okay, so 1 mole of aluminum reacts with 3 over 4. 3 over 4 moles of manganese dioxide. So that means we're going to multiply the moles of aluminum, 0.672, 0.672 times 3 over 4. That gives us a total of 0.504. All right, same thing the other way with manganese dioxide. So 1 mole of manganese dioxide reacts with 4 over 3 moles of aluminum. Right, and that's this divided by 3, and then this was just that divided by 4. More 3 moles of aluminum. Okay, so that means that this is going to be 0.328 times 4 over 3, and that gives us 0.437. Okay, so less moles of manganese dioxide than of aluminum, so we know that we know that manganese dioxide is going to be our limiting reagent. All right, so now that we know that, we're going to find the formula weight of our molar mixture. Oops. Where's the paintbrush? There we go. Okay, so to find that, we're going to set up the formula weight expressions that we've been working with all evening here. So we're going to have the moles of aluminum. That's going to be multiplied by the formula weight of aluminum. Grams per mole. And we're going to add to that the moles of manganese dioxide. Manganese dioxide multiplied by the molar mass of that, which is 86.94 grams per mole. That's going to sum up to the formula weight here that we're after. Okay, so we're going to use the moles that we have over here. So 0.672 times 26.98 plus 0.328 times 86.94 give us X grams per mole. There we go. And this gives us X being equal to 46.65. All right, so this here is the formula weight of our mixture, partially erased mixture here, with these percent weightings applied. So now we can divide the total mole. We can find the total moles present by dividing the 250 grams by this formula weight here, and that's going to give us how many moles we have. All right, so moles total is equal to the mass of the whole sample. I think it was 250 grams. It is 250 grams. All right, and that is divided by the formula weight that we just got from our weighted terms. Grams per mole. Grams cancel for moles. This gives us total moles of 5.359 moles. So this is how many moles we have total. And the portion of this that's manganese dioxide, we can multiply this same weighting by this to find how many moles of that we have. So moles of manganese dioxide equals our percentage weighting times the total amount of moles. 59 moles. And that gives us 1.758. 8 moles. All right. Nearly there. I think we might even do this without any more erasing. So now for the mass of manganese, right? Because the stoichiometry here is the same, then the moles of manganese dioxide are equal to the moles of manganese metal that we have left over. And so this is going to be the moles times the formula weight. So 1.758 moles. And that is multiplied by the formula weight for this is 54.94. 4.94 grams per mole, which gives us a total of 96.6 grams of manganese metal present after that reaction.